Hey, Annabella. Good morning. Morning, David. Oh, gotta get one thing. All right, good morning, guys. We're going to go over the homework and then go over lesson 2. And I think the Jumble Ed might be working now, but I'm not positive. So let's turn to the homework, which I think we've already done some of the problems. And I'm going to let Haley in here and open up a screen. And screen 1. And I think everything's working. Yep, everything's good. All right. We just need to get this even out. Looks great. Actually, we did some of these problems together, so I won't bore you, but I do want to, each of the homework problems are important to look at, and everything's important, but make sure you have the right answers to these, and then let me know if you have questions. The answer to this one, and I know I don't have numbers next to it, but you could write numbers next to it. That's 2. I believe this one is also 2. Yep. What is the product of these 2 numbers? I don't think I did that one. So there's one way to set this up that you may have not known. Remember, product means multiply. So you'll notice how I use an array model for these larger ones, but you can also just distribute. So this is a technique. I don't know if you guys are seeing a lot, so I'll just practice it one more time with you. 2 times 4 is 8. X times x squared is x cubed. Then you work your way right around the problems and multiply everything here by 3. And then you'll see a nice thing that happens. What I mean by a nice thing that happens is the diagonals represent the things that are like terms. So do you see how those are like terms and those are like terms? Good. Hunter's here too. So you get 8x cubed plus 2x squared minus 3x plus 18. Right? And I don't know what's the best way to look at this. You just look for the plus 2x, so you know it's 3 or 4, and then you look for the minus 3x, so it's option 3. All right, so that's how to tackle those. How do you write this in simplest form? Just make sure you distribute this negative to each term. That means everything in the sign changes. And then you combine like terms. And that's our answer for that one. And this is the last problem on the homework. The product, again, same idea. This time I'm going to do double distributive. So you can see both ways of doing it. You'll get 2x parentheses plus 7x parentheses minus 10 in the parentheses. And then inside the parentheses, you have x plus 5, which is distributed to all of them. And then you distribute, this is why it's called double distributive, because you then multiply what's outside the parentheses by everything inside the parentheses. I think it takes a little longer than the array method, but it's the same actual math if you look at the math. And so, you know, what's a few lines of math between friends? You know, it's just a little bit more math. Make sure you distribute the -10, not just the 10. So I think I got it all covered. Now we just need to combine like terms. So first of all, 2x and 7x squared is 9x squared. 10x and 35x is 45x. Oh, I have this other x. Make sure I have that right. Yeah. So minus 10x minus 50. And then we have 9x squared. I want to make sure I'm not missing anything. Oh, that should be cubed. That should be cubed. Because that was a squared. All right, so that changes this a little bit. This is 10x squared. Okay, so I was going a little too fast, but it's neat. This little thing is an eraser for pen. You just write it right over and it deletes everything. In a way like an old school delete, makes it disappear. What was I saying? Remember, I had this 2x squared. I should have wrote this as 2x squared. That makes this 2x cubed, and this makes it 10x squared. Now I have just a different grouping of numbers that I still have the 2x cubed here because there's no other cubes. But now I have these two to combine, which is 17x squared. Then I have these x terms to combine, which is 25x. And then I have the last number 50, and that doesn't change, and that's the right answer. And this QR code actually walks you through it. I believe it's a link to all the answers. So if you ever click on that, my friend teacher, Mr. Payne, made the videos. All right. Well, I should ask you, is there any questions on the homework on the back page? Okay, if there's no questions, I'll move on to the notes for today. Oh, I don't want pre-filled ones. I like to do fresh ones for you guys. Okay, this is solving linear equations and inequality review. Remember the most so the first thing to do is move the variable to either side if needed. So if, like in this first one, the variable's on both sides, and then you have to move the variable to one side by subtracting or undoing it. All right, make sure I'm recording here. I just want to make sure I'm recording. Oh, we're good. Okay. Next, move every term with x to the left and all the other numbers to the right. All right. And then isolate the variable to get all x's by itself. And that's it. So let's practice these. Those are the things we've been doing for solving equations and inequalities. It's not hard. I'm going to first move the variable to either side if needed. It's not a big deal. So I'm going to start with the smallest variable. I'm going to minus 6x from both sides. And I'm going to end up with 6x minus 6x is 0. And I'm going to end up with 2 equals 2x minus 6. Okay, now watch what I do here. I'm going to move the variable to the left. So 2x minus 6 equals 2. You'll see why I want to do that, just so that I have the variable on the left. And then I add 6 to both sides. I'm getting all the numbers to the right and all the variables on the left. So I have 2x equals 2 plus 6, which is 8. And then I have to get rid of the last number that's in front of x, which is 2. So that's x equals 4. Any questions there? All right, let's get, we know over here we have parentheses. And so we're going to get rid of the parentheses first by distributing. 4 times x is 4x. 4 times 3 is 12. Negative 2 times x is negative 2x. Negative 2 times negative 7 is actually a positive 14. And now once we distribute, we drop the parentheses. I'm going to move the x's to one side, so I'm going to add 2x to both sides. And at the same time, I'm going to minus 12 because I'm going to move the numbers to the other side. So 4x plus 2x is 6x. The 12s cancel. 2x plus minus 2x, that x's go away. 14 minus 12 is 2, and we still have the plus 3. Now, we have 6x equals 5. Not a problem. However, we have to divide both sides by 6. Is it okay to have a fraction as an answer? It is. And what the fraction is called 5/6. Just write it like that. Don't try to do the decimals. All right, I'm just going to keep going, and then you guys let me know if I'm going too fast, okay? To solve this one, we distribute first, remember? That's 5x minus 15 plus 2x equals 4x plus 12. Now at this step, I am going to combine like terms. I see a 5x and a 2x. So I'm going to add those to be 7x. And over here, I don't have any like terms, so I'll just leave them alone. And I minus 4x from both sides. And I add 15 to both sides. I'm moving the numbers to the right side of the equation and the x's to the left. 7x minus 4x. And then divide both sides by 3. Okay, let's take a look at the next one. More parentheses. Make sure you distribute that negative to each term. That can be tricky. Now I'm going to combine like terms if I see them. So I combine 9 minus 6 is 3. Negative 8 plus 27 is 19. Those are nice things to do in your calculator if you're not sure. Gosh, I feel like I'm doing too much of the work for you, but it's hard when you're virtual. You just need some examples, I know. So I'm going to move the x terms to the left side. So I'm going to minus 2x from both sides. Then I'm going to minus 3 from both sides to move the numbers to the right side. So what I end up with is 3 minus 3 is 0. Negative 6x minus negative 2x is negative 8x. And then we have 19 minus 3 is 16. Then I divide both sides by negative 8. We get x equals negative 2. Any questions on how to solve equations? Now we're going to review how to solve inequalities. If there are, when solving inequalities, remember we pretend the equal sign is the inequality sign. So, oh, we see. Yeah.
I actually do have a question.
Please.
For letter D, when you subtracted the -2 from -6, how do we know when it says -2? How do we know the difference between just subtracting regular 2 and subtracting -2?
Let's see, where we're right here.
Somewhere like right over there where it's -6 minus -2.
6
Right there, yeah.
Okay, -6.
Mm-hmm.
Oh, minus negative 2x.
I was wondering how you can tell whether it's just minus
yeah.
regular 2 or minus -2.
Oh, great question. It is a minus a regular 2. You can tell because we're actually, think of it this way. I don't know if you can, I'm going to show you a picture of how I think about it in my head, and this might help.
Gotcha.
These lines are represent combining two quantities. If I combine a quantity of 3 with a quantity of -3, do you agree they would come together to equal 0? Right? So what I'm combining is a quantity that's -6x, and I'm combining a quantity of -2x. And if you brought them together, they would equal -8x. Now, the question is, and it's a good question, is how do we know when it's like minus a -2x, or how do we know it's like plus a -2x? The answer is, these are always addition. When you write them like this, you're always combining them. So what we're really doing in this case is -6x plus a -2x. Now, I didn't write it like this, but what we're really doing is saying we're -6x and we're moving 2x, -2x to the left. And so we're at -8x is our answer. But the way we do it mathematically is add them. So we're actually adding a negative. We don't subtract downward and vertically. You know, when we do things from both sides, it looks like subtraction, but I'm really adding a negative. But adding a negative is the same thing as subtraction. So I could explain it both ways. Am I adding -2x? Yeah, I'm adding -2x. Am I subtracting 2x? Yeah, I am. Oh, it's off the line. I am subtracting 2x. It means the same thing. Yeah, good question, David.
Thank you.
Any other questions? All right. I was going to review inequalities, and then we'll get started on some of the Regents questions on your own, but I'll be here for support. So when solving inequalities, we pretend there's an equal sign. So we just treat this like an equal sign. So I'm just going to add and subtract variables and numbers, just like an equal sign. But when we reach an answer, we will show the solution set on the number line. Sure. If we multiply or divide both sides, this is a special rule. Maybe put a star by this rule, because this is an easily forgotten rule. If we multiply or divide by a negative number, we must switch the inequalities. So try to remember, if we multiply or divide by a negative number, we have to switch the inequalities. All right, so it goes from greater than less than, the less than to greater than. All right, you might remember number lines like this. If this is 2 and this is 3 and this is 1, and I made the statement x is greater than 2, then the number line would be an open circle. Greater than means it goes to the right. So do you remember that? You guys want to refresh your memory. So do you remember this symbol does not have a line underneath? So is it an open or closed circle is the question, and it's open. And when it's greater than or equal to, if it says equal to, that means it's a closed circle. And by closed circle, I mean this. And when I say open circle, I mean this. Less than, open or closed. And doesn't that O look like open? Yeah, that's helpful. And this is closed. You can tell because it has an extra line. And do you agree the drawing of a closed circle has extra lines to shade it in? Just handy ways to remember it. Now, here's the inequality that we're going to solve. We're going to treat it like an equal sign at first, but we remember the rule. If we multiply or divide by a negative number, we must switch the inequality. All right, let's do this. So the first thing I'm going to do is move the x to the left side of the equation by minusing 8x from both sides, which is the same, like David was thinking, as adding a negative 8x or subtracting 8x. They're the same thing. And I'll do it one step at a time so we don't make any mistakes. That would be me not making mistakes. Through -3 minus 8. Well, let's say you're on the test and it's really stressful and you don't want to add integers in your head. Just use your calculator, and you can't put x in there. You can't put negative 3x. No, don't do that. Your calculator will give you the wrong answer. What I mean, I'll demonstrate the wrong answer. You'll say, oh, minus 8x. And when you press enter, you'll see, oh, it's negative 110. That is not the answer. What it's doing is the last time you put an equation in there and solved for x, it took one of the x values and is plugging it in for x. Well, x could be anything, so we don't use x in our calculator function for arithmetic. To find out what the x coefficient is, you just put negative 3, whoops, sorry. You put negative 3 minus 8. And then you just have to know the answer is negative 11. So that's why I write negative 11, but I have to remember the units are x units. So you'll notice how that negative 11 goes in front of the x. You don't actually put x in your calculator. I saw 3 people do that yesterday, so I just wanted to do a friendly reminder. Everything else stays the same. But I am going to now move the number to the right side by adding 21 to both sides. That's how we undo negative 21. So we have negative 11x is greater than, I'm adding 21, so that would be 33. Now I'm going to have to divide because that's the opposite of multiplying by negative 11. I'm dividing both sides by negative 11. Now what happens there is the left side goes to 1 because any number divided. Now we have to remember our rule. If we multiply or divide both sides by a negative number, we must switch the inequality symbol. So it switches this way. And then this is going to equal to negative 3. Then we were asked to graph it on the number line. So I put the critical number, negative 3. I do an open circle. And I read this as, this looks like the letter L. So that might help you remember it's less than. So it goes, it's what are numbers less than negative 3? Well, negative 4, negative 5, and so forth. And so that's how we do inequalities. Don't worry, I'll do some more examples. And they're not easy ones. Think about what our first step would be here. Distribute. So let's distribute to both sides of the equation. Notice how I'm changing the sign as I distribute into the parentheses. And 2 times 18 is 36, by the way. Negative 4 and 8, positive 5 is negative 20. A negative and negative make a positive. I'm going to combine like terms. 36 and 48 make 84. Negative 8 and 48 make, wait, did I do that right? No, negative 8 and negative 20 make negative 28. So I combine like terms so that I have, yeah, that's self-explanatory. And then I add 28 to both sides. We get 84x is greater than or equal to 168. Now, you might not know this, but 8 doubled is 16 and 4 doubled is 8. So I know that we can divide into that. So I'm going to divide both sides by 84. And those of you know that, what I just said is that x will be, now I'm dividing by a positive number, so we're going to keep everything else the same. X is greater than 2. So now we graph it. I have to show you the graphing. Critical number is 2. Open or close circle, close circle. Which way does the go? It goes to the right. It's greater than or equal to 2. Okay, no questions. We'll move on. Redistribute. Try this yourself. Use my notes as a helper guide. This has a lot of big numbers, I get it. So if you want help with the math, use your calculator or just listen in. 2 and 24 make 48. So 13 times 9 is 117. 13 times 18 is 234. Now that's a big mess, it looks like, but we have to slowly work our way through combining like terms. So we look at the m's and combine those. So 117 minus 20 is 97m. And those two together, if you add 48 to negative 234, you get 186 negative. And don't forget the symbol, and it's negative 186. But is it? Now I'm going to add 186 to both sides. Now, if I did this right, I want to double check my math because I always worry. I mean, because it's coming out to 0, which is fine, but it does make me think, like, did I make a mistake? I get nervous sometimes. I'm like, did I make a mistake? Right on camera, that would be embarrassing. So handy dandy calculator will help us. It's 234. Negative 186. So we are correct. I'm adding 186 to both sides, which makes this 97m greater than or equal to 0. Now this is a weird one, because if what number times the variable is greater than 0, well, if there's only one number m could be. All right. That means m must be greater than 0. And that's by dividing both sides. Anything 0 divided by anything is 0. So even if I divide both sides by 97, still get 0. Okay. Oh, I didn't do my number line. 0, and it's greater than, and it's open circle, I believe. Yeah. All right. Any questions there? And then we have the practice ones. Guys, I want you to start number 1. Oh, by the way, I'll label these to help us talk about them. So I'm going to follow the sequence 1, 2, 3, 4, 5. You know what to do. 6, 7, 8, 9, 10. So much work. All right, try number 1. Don't worry, I'll come back here and help you with it in just a moment. I'll be yeah, right back. I just need to get it. There it is. Got it. Never mind, I don't have to go anywhere. All right, so this first one, you should have option 1. Let me just double check here. Should be 8.25. And I'll just leave it at that. Okay, try number 2. Or any questions on number 1? All right. Hey, I don't want to do all of them for you, but I do want to get you started. Anyone have questions? No questions? Okay, keep working. You might forget how to do number 3, just a helpful hint. There's a couple ways to do it, but I'm going to show you my favorite way to do it. And you see how they all have denominators of 6 and 3? Find the largest number that you can multiply that gets rid of these denominators. I'll show you what I mean by that. So x minus 2 over 3 plus 1 over 6 equals 5 over 6. Well, that's a hard equation to solve in this form. So watch what I do. I'm going to multiply the whole equation by 6. Multiply by the largest denominator that all the numbers go into. And then I multiply this by 6, and I get 2 times x minus 2. Because 6 divided by 3 is 2. That's where the 2 comes from. 6 divided by 1/6 is just going to be 1. 6 divided by 6 is 1. And then 6 divided by 6 is 1 times the 5 is 5. Now this equation is much easier to solve. That's why I multiplied by 6, because it gets rid of all of the denominators. This becomes 2x minus 4 plus 1 equals 5. And then 2x minus 4 plus 1, that's going to be minus 3 equals 5. Well, that's an x. So 2x equals 8, and x equals 4. All right. And if you didn't get that far and you're still working on number 2, I don't mean to rush you. You certainly are welcome to just write down the problem, and then that's fine. Now, don't forget, sometimes problems don't have solutions. It's not something we do a lot in math, practicing problems that don't have a solution. because it's not always helpful. But there are problems that you'll set up that don't have solutions like this one. So we'll see how that works, and we'll show you how to write the answers. There is an answer to the problem that has no solution. Isn't that weird? It's really just a way of saying we don't know. All right, so I'm going to add x to both sides. And I'm going to minus 4 from both sides. And so if I minus 4 from both sides, I get over here minus 5. And if I add x to both sides, I get 0 equals negative 5. And that's not valid. So we say empty set, or we write no solution. That's a special one. Is when you come up with an equation and it's invalid, that's how you solve that. All right, and that is it. If there's no questions, class will be ending shortly. I can give you answers if you'd like them for the homework. Let's just go over them tomorrow, I guess. Unless you have a question on a specific one before you go. All right, have a great day, guys.